everyone. So in this class we are going to discuss about Modi method, that is modified distribution method. This method is also called UV method because we are going to introduce here two variables, that is U and V, and need to calculate the optimal solution. So the same question what we have discussed in our previous class, for the Vogel's approximation method, the same question I have taken here and will see for the optimality test. Let us start the class. This question I have taken, and the initial basic feasible solution for the question was 102. Let us see, this is our optimal solution or we can find a new optimal solution. First, to check for optimality, we have to check the number of rows and number of columns. If you see the number of rows 3 and number of column is 4. And what are the allocations? Number of allocations? The number of allocation is 6. What we have already discussed. Let us see the allocations where we have done the allocations. So here we have 1, then 5, then 1, six, 3, 1. These are the number of allocations. This is 6 allocations we have got in our previous class. This is already discussed and we got the solution 102. So how to proceed for the optimality test? First we need to check the number of rows and number of columns. If you see the number of rows 3 and number of m plus n minus 1, that should equal to the number of allocations. This is our first step to see that this is satisfied or not. After that only we can go for optimality test. So what is the number of rows? If you see, number of rows is 3 and number of column is 4. So 7 minus 1, 3 plus 4, 7, 7 minus 1, that is 6. So this is equal to our number of allocations 1, 2, 3, 4, 5, 6. So we can go for the optimality test. This is our first step. What is our next step? Next step is we have to introduce two variables here. Those variables are called dual variables, U1, V. So the first step is we need to do for the allocated sets. Where we have allocations, for that only we have to find the U1 V value. So here if you see, one way of doing this is where the maximum number of allocations there, in that case we assume U. See how first need to do the things. This is number of rows, I can denote like this, U1, U2, U3, and number of columns I can denote like this, B1, B2, V3, V4. This is two variables we have done here. What we need next? What we need to do? We need to see where the maximum number of allocations are there. Here, if we see in this row, 2 allocations are there. For this it is 1, for this it is 3. In column wise if we see, here 2, here 1, here 1, here 2. So for this case, what I need to do, here the maximum number of allocations will be there. It's better to take that as 0. Assume that as 0. For the allocated cells only, we are calculating the U1 V value. So U3 equal to 0. Otherwise, you can assume any U as 0 and find the value. But it's better to, where maximum number of allocations will be there, it's better to assume that value so that we can get our U1 V easily. So here I have assumed U3 equal to 0. So if you calculate for V4, and there is a formula to calculate U and V, that is Cij equal to Ui plus Vj. Cij equal to Ui plus Vj. What is Ui? Ui is nothing but U1, U2, U3, the number of rows. U. And what is V? V1, V2, V3, V4. How many number of columns will be there? In that way we can denote. Cij is nothing but our cost. What is given in the table or the matrix. So Cij equal to Ui plus Vj. Cij means 9. 9 equal to 0 plus V4. So what is V4 value? V4 equal to 9. Means 0 plus 9 equal to 9. You can calculate like that only. So if you see here 15, Cij is 15, that is 0 plus V3. So V3 equal to 15. For this is also U3 equal to 0, means height equal to U3 plus V1. Height equal to U3 plus V1 means V1 equal to 5. In this way, we will calculate V1, V3 and V4. What is the value of U2? For U2, if you see, means 1, Cij is 1 here, 1 equal to U2 plus V4. Means here I can write 1. This is Cij. Cij means 2, 3, 4, 1, 2, 3. Means this is second row and fourth column. So I can write like this. C second row and fourth column equal to U2 plus V4, which is equal to 1 equal to U2 plus 9. So what is U2 now? U2 equal to 1 minus 9, that is minus 8. Right? Like this, we have to calculate the U1 and V2. So U1 and V2. How we can calculate U1 and V2? We can calculate, here we have V1. So we can calculate U1 here. Okay. So C11 equal to U1 plus V1. C11 is nothing but 2. 2 equal to U1, because U1 हमको पता नहीं है, and V1 is 5. So U1 equal to 2 minus 5. 2 minus 5, that is minus 3. Only one left now, that is V2. So how to calculate V2? V2 equal to 3. Here see this one, 1, 2. 3 equal to minus 3 plus V2. Here C12 equal to U1 plus V2, which is equal to 3 equal to U1 हमें पता है minus 3 plus V2. So V2 equal to 6. So all the value u and v value we have calculated here. Now this is for the allocated cell. For the unallocated cell जहाँ पर allocation नहीं है, for that what do we need to do? We need to calculate the delta ij value. What is delta ij? Delta ij equal to Cij minus UR plus Vj. This is the formula to calculate for the unallocated cells. जहाँ पर allocations नहीं है, for that case we need to calculate Cij. Delta ij equal to Cij minus Ui plus Vj. Let us calculate the value. And how we are going to find this delta ij? Delta ij for each unallocated cell, delta ij value for the unallocated cells should be greater than equal to 0 for our optimal solution. If all the value of delta for the unallocated cells is greater than equal to 0, then we will get the optimal solution. This is the formula for to get the delta ij value and for optimality test. So for the optimality test, we need to check that delta ij should be greater than equal to 0. Ui plus Vj is called the implicit cost for the empty cell. Cij is called the actual cost. So we need to compare those. So for that, what we need to do? We need to calculate the delta ij for the unallocated cells. Let us calculate the delta ij value. As we all know, delta ij equal to Cij minus Ui plus Vj. So here, what is Cij? This is unallocated, this is unallocated, these are unallocated cells. So we have to calculate the delta value for the unallocated cells. So here if you see, this is first row and third column. How we are going to calculate delta first row and third column equal to, this is Cij value 11 minus Ui plus Vj. What is Ui? Means U1 plus V3, that is minus 3 plus 15, which is equal to 11 minus 12. 11 minus 12 means minus 1. So we can write here minus 1. Like this we have to calculate for each unallocated cell. Now calculate for this one. This is 1 4 delta 1 4 equal to, this is 7 minus 3 plus 9, which is equal to 7 minus 6 equal to 1. So here the value is 1. This is minus 1. This is plus 1. Now we will calculate for this one. This is delta 2 1, which is equal to 1 minus 8 plus 5, which is equal to 1 minus 8 plus 5 is minus 3, which is equal to 4. So this one is 4. This is delta, this is 2 and 2, which is equal to 0 minus 8 plus 6, which is equal to 0 minus, this is minus 2, which is equal to 2. Here I have written 2. this 6, this is delta 2, 3, which is equal to 6 minus 8 plus 15, which is equal to 6 minus, this is 7 actually, minus 8 plus 15, so 6 minus 7 means minus 1. So here minus 1. Now 1 left here. This is called delta 3, 2. Delta third row, second column, which is equal to 8 minus u3 0 plus 6, which is equal to 8 minus 6, 2. So here the value is 2. Now these are our delta value. Delta value writing in red color. Maybe this will be prominent. This is minus 1. This is minus 1. This one 1. This is 4, 2, 4, 2. This one is minus 1. And this is 2. We have done with the delta value. Let us check the delta value. If you see that we should want delta ij should be greater than equal to 0, but here we are getting two negative value, minus 1 and minus 1. So this is not a optimal solution. So this case, this is not a optimal solution. We need to go for the optimality test or the iteration. This is not an optimal solution. So for this we need to go for the iteration process. For the optimality test, first iteration we need to do. So how to do the iteration? Here two negative numbers are there. We have to identify the most negative number or most negative delta ij value, because we need delta ij should be greater than equal to 0. As we are getting negative, so we have to identify the most negative delta ij value. So if you see here, the most negative number we are having a tie here, that is 2, minus 1 and minus 1. We need to draw a closed path here. How we need to do a closed path? Some rules are there for the closed path. That path will start from the delta ij value, but it will go through the allocation cell. Means the delta will start the closed loop from the delta value, most negative delta value, and the path will pass through, or the corners of the path should have the allocations. Otherwise, we are not able to trace the closed loop. If you see, here two negative numbers are there, minus 1 and minus 1. We can take one arbitrarily here because both are same. We have to, otherwise we have to choose the most negative number. So let us do the first iteration. This is called the first iteration. How to find the closed loop? This loop will start from here and it will always in clockwise direction it will come, and this loop will pass through the allocated cells. allocated cells. Means every corner we should have one allocations. Here we are having one allocation. Here we have having an allocation. Here one allocation. So now we can proceed like this. If you see here, only horizontal and vertical lines we can draw. Any diagonal lines are not permitted for the closed loop. And the closed loop should be a clockwise direction, not in anti-clockwise direction. And it needs in every corner a allocated cell so that we can complete the loop. The loop will start from the delta value, but it needs the allocated cells to complete the loop. So here it is a negative number, make this one positive. And the alternative corners positive, negative, positive, negative, like this. Delta ij will be the most negative number. Here we have started our loop. The loop continued through the allocated cells, and here we closed it. Mark this as the most positive, is a positive sign, and the alternative corners are negative, positive, negative. Positive sign we have to put here. Then the alternative corners will be negative, positive, negative, positive, like this. Now what we need to see? What is the next step? Next step is we have to see where there is in the closed loop where there is a negative sign and the allocated cell. If you see, it is negative sign is here and the negative sign is here. These are two allocations. What is the minimum allocation? Minimum number of allocation for the negative sign. Negative sign here we are having, here also we are having. The minimum allocation is 1. So we need to add this allocation here, subtract from here, add this here, and here also subtracted. Let us do the steps. We need to draw another table. Let us draw the table. What do we need to do? We need to draw another table like 1, 2, 3. This is 1, 2, 3 and 4. What do we need to do? We need to find the least allocation for the negative sign cell. So see, here we are having negative, here also we are negative, but the least is 3, here 3, here 1, so least is 1, we are taking 1. What do we need to do? We need to add here, subtract from here, then add here, and this is also subtracted. What do we need to do? Now see here 2, 3, 11, 7. This is 1, 0, 6, 1. Height weight 15. This is 9. So what do we need to do? We need to, this one will be added here. So here we are getting one allocation now. This allocation will be added here. So we are getting one allocation now here. This is our 1 allocated to this cell plus 1. Here minus means 3 allocated tha. 3 minus 1 is 2. Now here the allocation is 2 now. Here the allocation is plus means 7 now. Now here there is no allocations. But previously we are having here allocation 5. So mark this one 5. There will be no change for this case, because the loop can go through the allocated cell, but we need to do with the corners only. Okay. So here 5 allocated, it was previously there. So here 1. Another one is here. Now also if you see, we have 6 allocations. Now need to calculate the total cost. Let us calculate the total cost now. The total cost now, let us calculate the total transportation cost, which is equal to 5 into 3 plus calculate the total transportation cost, that is 5 into 3 plus 1 into 11 plus 1 into 1 plus 7 into 5 plus 2 into 15 plus 1 into, this is equal to 15 plus 11 plus 1 plus 35 plus 30 plus 9, which is equal to 3 into 5, so 15 plus 11 plus 1 plus 9 plus 30 plus 35, which is equal to 101. So 101 actually, the total cost is 101. So our initial basic feasible solution we got from the Vogel's approximation. The total transportation cost is 102. We have done the first iteration. This is 101. For the first iteration, the total cost total transportation cost equal to rupees 101. This is optimal or not? Need to check again. Again we have to go for calculating the U and V value. Then we have to calculate the delta ij value and we will check for the optimality. Let us start with the U and V value. U1, U2, U3. Then V1, V2, V3, V4. Assume this one as 0. What we have done previously? Assume this one as 0. So what will be V4? V4 will be 9. This V3 will be 15. This will be 5. Now what is U2? U2 equal to Cij equal to U2 plus 9. So 1 equal to U2 plus 9. So U2 will be minus 8. Then for this we can calculate as V3. U1 we can calculate here, that is 11 equal to U1 plus 15. So U1 equal to 11 minus 15, that is minus 4. Now we can calculate V2. V2 we can calculate here as Cij equal to Ui plus V2. So V2 equal to Cij equal to 3 equal to this plus V2. So V2 equal to 7 now. So this is our U1 V value. Now we need to calculate the delta ij value and check if delta ij should be greater than equal to 0 or not. If it is greater than equal to 0, all the values, then we can go. This solution will be our optimal solution. This cost will be our optimal cost. Let us calculate delta ij value. Let us calculate the delta ij value for all the unallocated cell. As we all know that delta ij should be greater than equal to 0 to check the optimality. So first for this one, this is 1, 2, 3, 4, 1, 2, 3. For this one, delta Hs would be actually 2 minus, this is minus 4 plus 5. Minus 4 plus 5 is 1. 2 minus 1 is 1. So I am writing delta H value in red color. This will be 1. For this, we can calculate. This is U1 plus V4. That is minus 4 plus 9 is equal to 5. 7 minus 5. 7 minus 5 is 2. For this, we can calculate. That is U2 plus V5. That is minus 8 plus 5. That is minus 3. So for this 1 minus 3. 1 minus 3 is 4. For this minus 8 plus 7. Minus 8 plus 7. So it is minus 1. 0 minus 1, that is plus 1. For this it is minus 8 plus 15 is equal to 7. So 6 minus 7 is minus 1. For this we can calculate 0 plus 7, 7. 8 minus 7 is 1. So these are our delta value we got. But still we are getting a negative value here. So this solution is not the optimal. Means this total cost is not the optimal cost. We can go for iteration process for the more optimality test. So again the same thing we need to do. We need to draw a closed loop here. Let us draw a closed loop. That loop should be in the clockwise direction like this. Here one allocation is there, so we can go like this. Here this side we cannot come, and the closed loop should be in a clockwise direction. So here we can move, from here we can move. This is allocated cell, and here also we can move, and we can come back here. Mark this was as this is positive, then negative, this is positive, this is negative. Now we need to find the negative sign and the least allocation. Here we are having a negative sign, here also we are having a negative sign. Here the allocation is 2, here is 1. So the least allocation or the minimum allocation we need, this is 1. This should be added here, subtracted, added and subtracted. Again we have to go for doing another table. Let us do it here. Let us draw another table and we will do the allocations. Here the negative sign we need to check and the least allocation we need to check, and we add with the positive sign and subtract from the negative sign. Let us do that. Here we can go for having one allocation here. Here there will be no allocation because 1 minus 1. Here we do one allocation. 1 plus 1 is 2 now. Here 2 minus 1 will be 1. Previously we are having one allocation here, that is 7. This is 5. Now how many allocations we are having? 6 allocations we are having. Okay. Let us see the cost. If we calculate the total cost, total transportation cost is equal to, this is our second iteration, this is our second iteration. Let's calculate the total cost. This is 5 into 3. 1 into 11 plus 6 into 1 plus 7 into 5 plus 50 into 1 9 into 2. So we need to calculate the total transportation cost for this new allocation. 5 into 3, 1 into 11, 6 into 1, 7 into 5, 15 into 1 and 9 into 2. If you calculate the total cost, then it will be 100. In our previous first iteration, we got 101. For this iteration, we got our total transportation cost equal to 100. This is a optimal solution or not, we need to check again. Again, we need to calculate the U and V value. This is U3, U1, U2, U3. This is V1, V2, V3, V4. So we need to check again delta value also we need to calculate to check the optimal solution or not. Let us first calculate the U1 V value. So U3, assume this is 0. Now V4 equal to 9, V3 equal to 15 and V1 equal to 5. Calculate U2 and U1. U2 equal to means 6 equal to U2 plus 15 and this U2 equal to 6 minus 15, that is minus 9. This is 11 equal to U1 plus 15. 11 equal to U1 plus 15. So U1 equal to 11 minus 15, that is minus 4. Now V2 left, we are left with V2. V2 equal to 3 equal to minus 4 plus V2. So this is 7. Now we are done with the U1 V value. Let us calculate the delta value for the unallocated cell. Now this is our unallocated cell. What is delta? Delta need to calculate like delta is equal to Cij minus Ui plus Vj. So let us first add Ui plus Vj, then we can subtract from Cij. Now for this minus 4 plus 5, that is 1. 2 minus 1 is 1. For this minus 4 plus 9 is 5. 7 minus 5 is 2. For this minus 9 plus 5 is minus 4. 1 minus 4, that is, this is minus 9 plus 5 is minus 4. So 1 minus minus 4, that is 5. Here minus 9 plus 7, minus 9 plus 7 is minus 2. So 0 minus minus 2, this is plus 2. Here minus 9 plus, this is 9, this is 0. So 1 minus 0 is 1. For this we need to calculate. First we need to add this one. 0 plus 7 is 7. 8 minus 7 is 1. So if we check, our all delta Ij value is greater than equal to 0. So this solution is an optimal solution and the optimal cost is 100. I hope all of you understood the modified distribution method. If you like the video, please share with your friends and don't forget to subscribe the channel. Thank you so much.